I will start when everything is ready. Don't hurry me actually to start like that. Some problem was there, I am rearranging. You have to play with the problems, not put pressure on me to start. See, this class actually is meant for the course which I am conducting, basic structural knowledge. All registered people, it is meant for the people who register for it and join the batch. But little portion I decided useful for public. Let everybody gain the knowledge. So important principle of drawing SFD and BMD, some lot of principles are there. I will tell one by one. Maybe one class may not be sufficient. One more class, 99, 100. You can make century class with perfect, more better knowledge. And next chapter, bending and shear stresses. That is a very powerful chapter. That also, I will most probably, I will stream public only. Then I will stop. Then I will continue with the regular batch only. At least this much useful for you. Voice clear? Rotating is not required, that we see that. Screen is turned. Is the screen also okay now? No. Is the screen also okay? Is screen also okay? No, just let me know. Is the screen okay now? Because some adjustment I have to do, that I will do next time. I have to cover the screen and make correct idea, because just last class only I started live. Last class only in YouTube I started live. So some adjustment required. Little lag will be there. There are some remedy for removing the lag. So one by one I will remove it. And one more information. Tomorrow I am starting column design and I will continue for foundation design. The most important part of the RCC for any structure engineer. Beam design, slab design, no problem. Maximum important is column design, footing design. So that I am running a batch here, ETAPS and SAFE, their structural knowledge. So only that column design part, and because I am there, even though it's a software class, already 21 classes are over for basic structural knowledge. So the closing part is column design with axial load and biaxial bending, and also footing design. That portion I am making public. Let everybody use it. Once that is over, then I will continue the class with the regular group only. Everything continued. There is no point in making a group. See, this is a professional job, but in between, I decided let it be useful, and in future also, depending upon the response, I may upload or take live classes on more and more important portions, and academic classes also, depending upon time availability. Okay, now, see, there is a problem today with me, little charge less, sir. Okay, I can manage. I can manage, I think. See, how to draw SFD and BMD. If any problem is there, let me know. Actually, I told to If a call comes to me, then screen gets turned. You remind me immediately in the chat box because I first switched it off. I not switched it off. I went to flight mode. Some problem in the Wi-Fi. So therefore, in the beginning, see, it did not get connected. Then it vanished. Therefore, I removed the flight mode. Therefore, phone is on. Therefore, what happens is, in case a call comes, problem will come. Nothing will happen. Screen gets inverted. You, in the comment box, let me know because I can't see there. Immediately I will go and cut the call and repair it. No interruption. What I told, if you go to flight mode, if Wi-Fi problem comes, mobile data cannot be used. Now I have to use mobile data. Unless I should now, once for all, I can settle it by barring incoming calls. I will try for that one. Not able to do it right now. See. Usually, when you draw SFD and BMD, you should, all things I tell here, you make a note. You should write a note. I am not writing statements all here. I am dictating. What I dictate, everything you write. So it is useful. What I told earlier, don't write. Okay. When you draw SFD, BMD, usual procedure is, see, loading diagram on the beam with support reactions, any reaction, okay. Loading diagram with support reaction, that is, you sketch the member in equilibrium. I told thousands of times, those who came to my regular class, see, this class is 99, 98 classes earlier. Of course, general public, they came yesterday, but no problem. What all in SFD, BMD I covered in this batch. Everything is there 10 times more in the course SFD BMD available in YouTube. See, it is for public. There, class number 100, I already uploaded and stopped for the reason. I am continuing that one. So, suppose you get some doubt here, anything like UDL, UVL, etc., all you have to do is go to YouTube, my channel, there, go to playlist. You can see SFD BMD. You can see there 102 videos. Actually, 102 classes. I don't call video. It is not a game or entertainment. 102 classes are there. Start from class number 1. Finish everything. Then do one thing. Right now you come live and understand. If confusion is there, start from class number 1, understand everything. Then you see here, you will be laughing. So easy. Everything explained. Remember, around 30 pre-requirement classes. In Kannada, you call PTK. Pre-requirement classes, 30. Sometime in colleges, 30 classes, they finish entire subject only. Okay, now. So, this is equilibrium. Below, you sketch SFD and BMD. Randomly I wrote. Below, you sketch SFD and BMD. Of course, both of them, you need sign convention. This I have been telling right from class number 1 in YouTube also, and for regular batch, this BSK batch, so many times I told. So first the loading diagram with beam in equilibrium with the load, action and reaction. This is the action, this is the reaction. Then SFD and BMD, draw it. Then where SFD crosses the baseline, locate that point. Locate that point. If it is already a known point, keep quiet. What you locate? You do not locate a known point, correct? You search for an unknown address. You don't search for your own house. You go in the road. When your house comes, you enter inside. You don't ask anybody, is this my house, like that? If you go some new place, if you don't know, you ask. Then find SF and BM, every standard point, locate that point, and then find BM at all the standard points, including this point. This point. If it is a new point, and then plot the BMD. I will tell you what all people make mistake. Actually, don't think that I am here to find out others' mistake. No, I am not that type. I somehow feel that way. You find out others' mistake and comment and enjoy. It is called sadistic behavior. I am not a sadist. My purpose is all those who make mistakes, let them rectify and know oh yes, this is a mistake I am doing. At least from today, I will not make the mistake. My purpose is to improve or make them to make no mistake at all, not for enjoyment. For enjoyment, what enjoyment I will get by finding mistake in others? I told you that is not correct. I will tell the mistakes because you should not make the mistake. See, now maybe I told today is class number 99. One class is not sufficient, I know it. No problem. Class number 100 will continue. That is next Tuesday. Because tomorrow and day after tomorrow, that columns and foundations are there. You are welcome for that also. That columns and foundation, you are welcome for column and foundation part only. Then class will be continued for the batch where I will send the link. That is in the Zoom I am taking class there. Those column and foundation I will take in YouTube. That is the maximum demand everywhere. Okay, now see SFD BMD. Now most important, I will write here. Don't tell, sir, how SFD came randomly. SFD comes this way, I will tell. I will set a question if you want where SFD comes this way. I can do it. So never bother how SFD came that way all. Randomly I drawn. Okay. Now some plus minus plus BMD. No, then the BMD will be this way. Maximum here. Okay. Now before you now when you draw SFD, sometimes see, first of all make a note here. In SFD and BMD, any one of them, either for only SFD or for only BMD or for both, either only for SFD or only for BMD or for both, okay, either only for SFD or only for BMD or for both. Now don't tell me what I am telling is for SFD or BMD. You so many times, case 1, you get constant. 1 minute. One case, nothing is there. It happens. Nothing is there. Nothing is there means, yes, it is possible. Nothing is there. Someone will tell, show it. I will show it. Whatever I tell here, I will prove it. Without proof, I won't tell anything. Nothing is there means what? Nothing. If nothing is there, keep quiet. Why should you bother? No diagram. Maybe some portion nothing is there. Other portion something may be there. You consider some portion of the beam. Nothing is there. Shear force 0. That will happen if a beam is subjected to pure bending. Bending moment 0. That will happen a special case. I will set the question for that one. In some portion, bending moment 0. Someone has told me earlier. Not possible. Suppose I make possible. Then he told, okay, no, leave it. Then he came to know this man can do anything. Therefore, it is possible. I will make it possible. No bending. How possible? Don't ask me. If you want, I will show it. Then see, if nothing is there, keep quiet. What to do? Keep quiet. Second one, constant. Remember, it can be either shear force constant or BM constant. Constant means you don't have to bother. Why? It will be parallel. If this is the baseline, see, if this is a baseline, either for SFD or BMD, okay. Constant means sign will be there, plus minus. Plus means upper side constant over, plus over. Minus means lower side right, minus over. Constant. So if constant also, for today's class, keep quiet. Why keep quiet? What you discuss for constant. So keep quiet. Over. Now, next important is linear variation. Linear variation. So many people, they tell linear curve. You please don't insult mathematics, I will tell. There is no term called linear curve. Curvature means there should be some curvature. Linear, what is linear curve? Linear, that's all. Linear variation. Linear variation also, you can keep quiet. Why? It won't come for your class number 99 and if required, class number 100. Who knows? I will tell so many things for you. Make it perfect. You should have patience. In my class, patience is required. Everything suddenly give. No, I won't give. See, in the beginning, someone commented there, start earlier. I was having a problem. I am rectifying it. I did not talk angrily. Nobody dictates me anything. In my entire teaching, nobody dictates me anything. I do what way I want. No dictation. I did not tell angrily then. I told then, wait, I will do it something. Please start earlier means how? I won't deliberately waste the time. Simply standing here like that. I have seen people walking round and round. I never do that way. If I want rest, I will see in between. See now, 5 minutes I may take rest. Because talking non-stop, for my age, it is very strenuous actually. So I may take rest. But I won't simply waste time. So linear variation. Today's class and next class will be on Tuesday, or who knows, if requirement I will make one more class or even 2 more classes also, no problem. When I do something, it will be permanent. No doubt should come. Those people who go through this class, in their lifetime, they should never make mistake of, they should have never have difficulty of deciding what, especially whether curve is like this, whether curve is like this. See, I told you, some 2 values to be joined. Imagine, linear, no problem, join. But higher degree, parabola of either 2nd degree or 3rd degree, doubt will come. Will it keep on going down this way, or will it go up and come down, or will it come down here and go up, or will it come down, cross the baseline and go up here? See, all these things will happen. Doubt will come. Most powerful doubt is, I will tell you, whether this way or this way. Most critical doubt. If I ask the question in the class, which way? They will tell sometimes, sir, simply support this way, cantilever this way. Why? Sir, why? We don't know. You don't know. Now you know it. Now is the time to know it. So many principles of this one, I sometimes never tell. Because no one told me. No one told me about this one. Everything I learned myself only. I never learned from a book call. I understood because my mathematics is not so bad. So anyway, remember, linear variation, therefore, see, if there are 2 ordinates are there, it can be SFD or BMD, whatever it is. I will come to SFD, BMD. Linear means join. There is no doubt. Sir, will it go this way? Linear. Straight line between these 2 points. How it can go this way? Oh, yes, sorry. People will tell, sorry. Okay. So linear, keep quiet. Keep quiet, but not keep quiet. I will tell you what mistake people are making. Right now I will tell. Remember it. I will give a simple example for you. See, very simple example I will give you. And remember, no proof, because why? Today's discussion is for variation. We are not bothered today about calculation of shear force bending moment. That we are doing class after class. 1 minute. I am not in chat box. Screen is tilted. See, again same problem. I don't know. Is the screen tilted now? Is screen tilted now also? See, I should see it. Is the screen okay or tilted now? I should tell first. Is the screen still tilted or okay? No, yes sir means I can't make out. Yes means what? You have to answer tilted or okay. You have to tell one of them. Yes means what? I told tilted or okay. One of them is still tilted. Why? What is the problem for tilting? 1 minute. See, these all problems I have to overcome. See, sometimes it happens that, are you sure you want to stop the streaming? No, cancel. Why tilted? I don't know what is the reason for tilting. 1 minute. In laptop it is vertical. For mobile, okay. For mobile, okay. Tilted means okay. Laptop you can tilt actually. Shall I continue? No problem. For mobile, okay means see in mobile. No problem. Full screen is there. If mobile okay means I will continue. Because till I get the grip on the setting, I can't do anything. In laptop it is vertical. Okay. For mobile, okay. If it is okay for mobile laptop, you can turn it. But voice should be clear. Is the voice clear? Tell me. Is the voice clear? Voice should be clear. Very important. Today's class maximum voice important. Voice clear? Voice clear? Okay. So mobile okay means see in mobile, or if it is laptop, turn the laptop. What is there? Okay. Next Tuesday, by Monday I will call someone, some expert. I will ask him to come and separate these problems. Some setting you have to learn. Okay, beat. Because 1 minute, let me see the mobile display once. Yes, okay. Mobile display is okay. I can see. No problem there. Okay. Now see, one example I will tell you. Linear, why I am talking? Take the simple, this I told you earlier. Take the simple example of a cantilever. This mistake people make in cantilever. See, a cantilever beam subjected to simply 2-point load sufficient, or 3-point load. 1 point load there, 1 point load here, 1 point load here. Now, some reaction will be there and reacting moment will be there. You don't bother. See, A, B, C, D. Now, draw shear force diagram. People will draw correctly shear force diagram. Okay. Don't bother. Why? It is constant. Draw the bending moment diagram. See. Now, this is suppose a 3 meter, this is 2 meter, and this is 2.5 meter. Okay. Now, see, 2 meter, 2.5, 3. Okay, reasonably okay. I have seen sometime people mark this way. See, they will see, especially not 2 meter. For example, this is 5 meter. They mark this way. They write here. See, 3 meter, then 5 meter. What is this first of all? So that I leave it now. Now imagine 2 meter. Okay. Now I don't require that values. Now what happens is scale is okay. You don't measure scale and doing the graph sheet. Eyesight scale. Okay. Now third BMD. Find BM here. Find BM here. Find BM here. See, imagine your BM at B is 0. Why you don't bother? BM at D is, imagine, see, this is the problem, end of the page. BM at D minus 60. Okay. Then BM at minus 60, say minus 20. BM at D over. BM at C equal to minus 90. And BM at A is minus 150 they got. Okay, correct. Why it came, you worry later. Start plotting. They will plot here. How much here? 20. See. Then 90, 150. See now, what is the blunder I will tell. By looking only you can make out this is complete nonsense. Will anybody will agree? When this is 20, this is 90, nobody will agree. It should have come how? I'll write here. It should have come like 20, 90, 90 and 150. Now see. This way. Now still further it will drop. It will come this way. Now it is okay. Now, if you draw this way, shape is okay. But what will happen is, see, for this line, slope will be equal to shear force here. I don't know what shear force. See, for example, shear force, I will tell this is 60, this is 40, this is 25. It's a shear force. Then, for this one, your slope should be 25. For this line, your slope should be 40. For this line, slope should be 60. Does it look? See, how much slope is there here? For this line, slope should be more. See, it should come this way. Because, why I will tell you. See, when this is 25, see slope here. Here, as per their diagram, it will become flat. No, it will become further steep. That is because of scale problem. So you should have some reasonable scale. Then mistake will not happen. And even for simple support beam also. See, just for example, some 2 point loads are there. SFD will come this way. For example, say this way. BMD, they will calculate. BM here. Something they will calculate here. See. Or one more point here. Then SFD will change. Okay. This way. Somewhere here. They will calculate BM here. It will come 80. See. They will put 80 here. They will calculate BM here. It will come 90. They will put 90. It will come 90. They will write not 90. It will come very high. 160 comes. 160. They will draw this way. See. Now, for this line, slope is this ordinate. For this line, slope is this ordinate. No. Wrong. Means they made a mistake in the distances. 80 and 160 possible. The diagram should have come this way. That means this is a large distance. They by mistake they wrote out of scale small. Then the diagram is completely wrong. Anyway, that I am not discussing today. So remember, if nothing is there, keep quiet. If constant, for today's class, no discussion. If linear also, for today's class, no discussion. Why? Your problem is not linear, means joined by a straight line. Over. Now, any problems are there? Hope no problem. Now come to the point of when parabolic, either parabolic of either second degree or third degree. Why it comes, you should know from basic of SFD, BMD. I will tell you briefly. Okay, now, see, before you start this variation, first remember, we have the basic equation. dV by, 1 minute now. Let V be the shear, I don't think now. No, we have. Let small w be intensity of load. Intensity of load. Not applicable for point load. Actually applicable for point load also. If you see my class number century 100 there, I made clear one powerful concept there. Okay, leave it. W be the intensity of load, that is either UDL or UVL. In UVL, either triangle shape or trapezoidal shape, anything. Intensity. And remember, if it is UDL, then intensity is constant. If it is UVL, then intensity W varies. That is the name, uniformly varying, UVL. So remember, see, anybody can make out. UDL is represented by a rectangle, constant. UVL by a triangle or trapezium, so there is variation. Means UDL intensity is constant, UVL intensity varies. So it is not constant. What is that? No, varies means not constant. Okay, now, before going further, okay, intensity of load, then let V be the shear force anywhere. M is the bending moment. Now, the most powerful, there is a relation between shear force and intensity of load and bending moment and shear force. See, first remember, we have different dV by dx. Anybody can tell me what is dV by dx? Okay, let my comment come. Anybody can tell what is dV by dx? dV by dx. What is that one? Anybody can know? Otherwise, I will tell you what. But whatever, I want to prove it. In my course SFD BMD in YouTube, very thoroughly this is explained with so many explanations. Maybe class number 34 or 33, you can see there relation between bending moment, shear force and intensity of load. So dV by dx is intensity of load. See, some principles I am telling, I won't repeat. Intensity of load, that is W, intensity. And anybody can tell, no, dm by dx is what? Tell me, at least tell that one. What is dm by dx? Dm by dx. Now slope I will tell you later, 1 minute. Dm by dx is shear force. That is V. Therefore, I will write something now, very powerful concept. Remember, I won't repeat. Mathematics. See, I won't hurry this class. Do you want me to hurry and finish fast? Tell me. Or take 2-3 classes so that once for all, for lifetime, it is clear. What do you want? Hurry and finish, or systematically explain. Take 2-3 classes so that universally, anybody, after going through this class, they should tell one thing. Now I am master or champion in deciding the type of curvature, etc. What do you want? Hurry and finish. 2 minutes I can finish now. In 2 minutes only. In my class, remember, patience required. I have infinite patience. I told you, in my class, I so far never got angry either online or offline or in colleges also for wrong answer. Why? Why wrong answer angry? If I get angry for wrong answer, I should be always angry. Why? When I ask a question, usually wrong answer only comes. I trap for that one. So, mathematically, see, if y is function of x, tell me what is dy by dx. Mathematical. That's why I will go slowly. Let it take 99, 100, 101, 102. Okay, no problem. 103 also. It should be a lifelong remembering for you. So that, see, you people should tell, so far such an explanation never came earlier and will not come later. Anybody should tell, difficulty is there, that class. Go through that class, learn everything and come back. Mathematically, see, that lag problem I have to overcome. I know there is a lag problem of around 10 to 15 seconds. I counted. I am trying in the YouTube and the Google also how to remove lag. They are telling, do this way, do that way. I am not able to do it. Why? Not expert in electronic media, in your social media. So, if the drag is removed, the lag is removed, like Zoom. The moment I ask question, comment comes immediately. Now see, I have to wait. Tell what? What mathematically is, if y is a function of x, what mathematically? Dy by dx. Tell what is dy by dx. See, this class I will take in the natural way, not with the stylish language. Say, now, if y is a function of x, what is dy by dx? I never talk that way. I talk the way I talk in our day-to-day life. That is more important. Stylish language, leave it. Tell me, no slope. Dy by dx actually is equal to mathematically tan theta. Tell yes or no. Dy by dx is tan theta. Just you can tell yes or no if you know it. Tan theta is always slope. Slope is always defined by tan theta. That is called slope. Correct? Slope. And other thing, other way of explaining, tell dy by dx is tan theta. Tan theta means slope, not theta. Theta is the angle. Tan theta. Okay, both are same. Okay, now, other way you can tell dy by dx by one more language. Anybody can tell? Dy by dx, you can tell by one more language. See, mathematics is perfect. There is nothing in structural engineering. Nothing in structural engineering. If you are mathematics, what? Not complicated. Simple mathematics. If it is clear, there is nothing. Simple example. I told earlier, 2 into 3, how much? 6. 3 into 2, how much? 6. Both are same? All will tell, yes sir, both are same. No, for me both are not same. If you tell 2 into 3, to my mind and inner mind, I can see 2, 2, 2, 3 times. It comes to my mind. And if someone tells 3 into 2, 3, 3, 2 times will come. Both answer is same. 2 people working for 3 days or 3 people working for 2 days. Amount of work may be same, but result may be same, but involved people, it is not same. See, it took 3 days, this took 2 days. So that mathematical concept, suppose you make 4 plus 7. When you make 4 plus 7, 4 plus 3, simple, 7, answer. My case, what happens is, when you tell 4 plus 7, within my brain, it works. I can see that 5 and 6. From 4, when I go to 7, I can see that 5 and 6. I know, after 4 to 7, you have to go through 5 and 6. It comes naturally. If that way mathematical grip is there, structure is nothing. Tell the answer. There is one more way of telling dy by dx. Let me see anybody. Oh yes, very good. It is called rate of change. Rate of change. Rate of change of, here, rate of change of y with respect to x. See, simple example I'll tell you. If y equal to x square, what is dy by dx? All will tell, sir, 2x. Tell y. Sir, formula. What formula? Sir, nx power n minus 1. No. Formula don't use. Formula is not there. What you will do? Sir, then nothing can be done. Why nothing can be done? I will do it. Limit as delta x tend to 0 of what? Y of what? X square. What is that one? X plus delta x whole square minus x square divided by delta x. That is dy by dx. You change x by a small increment delta x. Then see how much y will change. Then that dy, that rate change of y ratio to x, limit as delta x tend to 0, that is called dy by dx. Simplify, it will come 2x only. Okay, leave it. Some will tell, ayo, what to do. These are all should be in inner mind. So it is also called as rate of change of y with respect to x. Okay, now one most important part. See, this I will tell once. See now, see here. I won't write once again. Rate dV by dx is intensity of load, dm by dx is shear force, or you can tell using this language what? Rate of change of shear force equal to intensity of load. Intensity of load, and you can tell here rate of change of bending moment equal to shear force. And also you can tell one more thing. That's what I want. Write in red colors. That finally what we want is dV by dx equal to W. Some people tell, comment, no, it is not W. What is then? Minus W. Keep quiet, I will tell. He will tell, no sir, it is minus W. Who told you? All books, throw that book, I will tell. I proved it in the BMD class. Don't tell minus W. Tell W, intensity of load. If that is, if you start from left side, do from right side. Then he will tell, oh yes sir, there plus came. I was not knowing. You are not knowing, therefore keep quiet. Don't comment. If it is guaranteed minus W, I would have written it. I am not that much weak. So you don't remember plus minus sign. I will tell you that one later. So dV by dx W means what? Mathematically, you can tell rate of change of shear force equal to intensity of load. Intensity of load. And also remember, differentiation is always slope. I told you. Slope, or you can tell slope of SFD equal to what? Tell me. Final conclusion. This is what we want. Slope of SFD is always, tell the answer. See, dV by dx is rate of change, but actually that is nothing but slope. Therefore, final conclusion, other things we don't want, I will write somewhere there later. Slope of SFD is what? Intensity of load. Don't forget. Or you can tell slope is intensity of load. Intensity of load. Loading. Okay. Loading. And then come to this one. Come to this one. Okay, start. If you write dm by dx, red color, dm by dx equal to v means what? You can tell. That means rate of change of bending moment equal to shear force. Correct. Or, but you know that dm by dx is nothing but slope. Therefore, you can conclude one more box here. See, one powerful box here. Slope of SFD is intensity of load. Thank you. You all go. All of you go. You stay back. You tell it. You stay back. Because this is highlighted. You stay back. All of you go. Or you can tell what? Slope of BMD equal to, answer. Slope of BMD equal to what? Slope of BMD equal to. Slope of BMD equal to. Shear force equal to, okay, I will put SF, no problem. Time space is SF. Tell all of you go. You stay back. You stay back. Therefore, I will write here, permanently remember. Permanently remember in future. I will tell one by one. dV by differentiation of dV, V means shear force. I want to write here. dV by dx is rate of change of shear force is intensity of load, but you know that rate of change means always slope. Therefore, slope of shear force diagram is intensity of load. Slope, permanent remember, first for slope means slope for SFD. The slope is very important to decide the curvature. I will tell you later. See, why you are highlighting slope? Because the slope will decide you the curvature, whether it goes this way or whether it goes this way. That's why so many things, all this is 38, 39 years. I never told these things all. Why? Academically, who wants that one? That much not required. I ask the question. People will tell, sir, please tell, sir. I will tell later. Time has come now. I decided once for all, so many extra concepts I know, instead of keeping with me, not one or two, plenty thousands are there. Better make public. So many things, better make public. Why? Let it be known. Even after me also, it will be remembered. See, first, for slope of SFD, the principle is what? Slope of SFD is intensity is equal to intensity of load. Intensity of loading or load sufficient. This is for SFD. So remember, when you connect SF, you connect with intensity. Therefore, if you want to decide slope for SFD, where you have to see, always look up. Why? Not look down. If you want to decide the slope, this I will not repeat once again now. Over. I will tell you, take a screenshot and paste on your study room. Okay. If you want to decide slope, why? If you want, I don't have to decide. Someone will ask, sir, if we want to decide, no, don't include me. I don't require all these things. If you want to decide slope for SFD, see what? See what? Tell me. See what? If you want to decide slope for SFD, see what? See what? No, see loading diagram. See loading diagram. Correct now? Loading diagram. If you want, see, this is one part. See loading diagram. Loading diagram will tell you intensity of load. Clear or not? See loading diagram. Okay. Now, second point. This is a point number 1. Second point. In a box for slope for BMD. Slope for BMD. See. Slope, you can write dm by dx equal to shear force. Dm by dx is rate of, all told here, rate of change of bending moment is shear force, but we know that rate of change dy by dx or dm by dx, dy by dx is slope for that curve. Why? Here curvature means for bending moment. So for slope of BMD is equal to shear force, and therefore C loading diagram means C upper side. Why? I told you loading diagram, shearing force diagram, bending moment diagram. To decide slope in any diagram, always C up. Some will tell, sir, suppose you draw BMD first and then SFD. I have not seen any people doing that way. Systematic is SFD first. Suppose, sir, I do BE and then I do diploma. What I can tell? Do it if you want. But you can't do BE first, then PUC. That is not possible. Such questions, no answer. If I eat first, then cook. What I can tell? Okay. For slope of BMD shear force, therefore shear force intensity of the slope of shear force intensity. Therefore, for slope of the BM, see, slope of SFD, slope for SFD, C is intensity of load. Okay, intensity of load. Same way. Therefore, I wrote here slope of BMD, slope is shear force. Therefore, if you want to decide slope for BMD, then see shear force diagram. Again look up. Why? Because usually we draw loading diagram below shear force diagram, below bending moment diagram. Now, so remember now, permanently this will be removed up to end of this class of variation. Maybe one class not possible, I know it. Maybe to take 2-3 classes more, no problem. Throughout this explanation, when I start next couples, then I will not tell once again. When I come to continuation of our SFD BMD, that is couples have to do, very important once again. That also I will make public. I told 2 chapters will be public. Okay, now I will just tell, see written there. You shouldn't tell where. Where means here. So if you want decide slope for SFD, see the loading diagram. And if you want decide slope for BMD, see the shearing force diagram. How is the intensity of load? That is the shear slope for SFD. What is the shear force? That is slope for BMD. These are important. Now, a question will come. Suppose for a beam, you don't draw SFD. Only BMD drawn. What to do? For me, no problem. I know what to do. I don't draw SFD. If you want decide slope of BMD, I will not see what is the shear force variation. Why? Because look at the beam, I can make out. I will tell a trick for you also later. Without seeing SFD, you can draw BMD. You can decide the curve using a special trick. See, one trick, or that's all. See, One trick is, I will tell easy way. If you can hold water, yes, one trick. Or if you put water here, water stays. Or if it is this way, water will flow. That's all. What I will tell later, not now. At the end of this class, this part, I will tell you easy way to decide the slope for BMD or curvature for BMD without seeing SFD. If you go to interview, see, sometimes it's possible. Some frame problem I seen, they will tell this way, they will tell BMD, will it come this way, or they will tell, will it come this way? See, will it come that way or will it come this way? I will tell the trick for you, not now, little later. Some crude method is there. See, very simple to understand. I will tell, if this is the way you put your hand, if you pour water, water stays. How is the curve? Or if you put this way your hand, if they put water, water will flow. That's all. Then people understand. See, always crude method, people understand very fast. Okay, now this is clear. All I am doing now, just tell me, all these discussions, fully clear, fast. All these discussions, fully clear or not? I will go to one by one example now, so that every doubt I will clarify. Nobody should have any doubt for drawing SFD BMD after these 3-4 classes. Everything clear I told? For slope of SFD, see load intensity. For slope of BMD, see shear force. SFD. Okay, clear. Okay, now I will give one simple example, then take 3-4 minutes break because non-stop talking. See, I will take a case of one thing forgotten. I should tell now only. Also note, for if y is f of x, then for y to be either maximum or minimum, dy by dx should be equal to 0. That is what? Slope should be 0. Slope should be 0. That is what? Tell me, see. Suppose a curve goes this way, y. See here, any curve goes this way. And this is the y maximum. At that point, if you draw a tangent here, the slope there should be equal to 0. See? Or, this is, see, for example, this is the curve. From baseline, some curve this way. Or, sometimes, a value comes here, curve can come this way also. Then, this is not maximum, this is y minimum. Even here also, draw a tangent, slope should be 0. Therefore, usually remember, maximum is very important. 99% problems, it is maximum. Rare cases, in overhanging beams all, you get minimum. Otherwise, under normal case, under abnormal case, it comes minimum. Or people will always tell maximum only. So, same way for y to be maximum. See, we know that for y, see, for y to be maximum, dy by dx 0. Same way for bending moment m to be maximum, dm by dx should be equal to 0. But you know that dm by dx is what? Tell me. You know that dm by dx is what? That is the slope for BMD. This is slope for BMD. Slope for BMD or further, what? dm by dx, further. It is a slope for BMD or further. Either you can tell slope for BMD, yes, slope 0, or you know it, shear force. You know dm by the shear force. Therefore, I will remove all this one now. One more to remember. For BM to be maximum or minimum, rarely minimum, then shear force should be 0 or 1 meter. Minimum, I tell you, slope for BMD there should be 0, or you can tell shear force there should be 0. But remember, not valid for cantilever. That question I am going to ask in YouTube under a special brain twister. Let the people answer. Beautiful answer is there. Okay, now beyond the limit I will not go here. So remember, bending moment is maximum, usually maximum or minimum. It is called local maximum, not entire beam. For that region where shear force equal to 0, or either shear force 0, or see, that is either shear force is absolutely 0, or you can tell where SFD crosses baseline. That happens under point load. Either it, or see, that is, see, either shear force diagram should be 0, see here, 0, or this way, plus to minus, see, plus minus, you can write here. Either it is absolutely 0, or see, it crosses the baseline. This side positive, that side negative, because under a point load, you tell shear force just to left and just to right. If just to left is positive and just to right is negative, yes, that there is a point of 0 shear force there. This I told you in class number 100 of SFD BMD course, century class. It was something which I was holding back for more than 30-35 years. Now I decided recently, okay, let the public know it. So I have given beautiful example there, and you go through that class number 100 in the playlist, SFD BMD, that's the last video uploaded there. Not video, class uploaded. Okay. Remember this also, now see, therefore see, if you go this way, slope 0, this is slope 0. So BM to be maximum or minimum, dm by dx should be 0, that is slope should be 0, or what you can tell, slope 0, or you can tell shear force 0. But remember, if the SFD crosses base, if the SFD is this way, shear force is 0, then correctly 0 will come. If it is this way, then either side slope should be, one slope is this way means other slope should be that way. See, if the curve comes this way, see, if a parabolic comes, etc., maximum point, slope 0. Here, separate slope will be there. Or you can tell, see, from anti-clockwise, it has changed over to clockwise. Actually, this curve, actually not that way. It is actually, see, I told, even though you put that way, it is actually like this. For a small loaded length, it is actually 0. All this, make a note. I will start one by one example. Now 1 minute. I told I want a small break. Yes, I will take now, because then I will come back and today give a very important example for you. Okay, 1 minute now. I will write a sketch here, and this I will remove now. All I am removing. See, I will start one by one. See. Simple example. A simply supported beam, see, you apply some point load, any number of point load, this way. See, I am not going to put the values, I will put the values later. This is a beam. Draw SFD. Imagine SFD comes this way. See, this is SFD. Values are not required. SFD. Sign all I am not writing. But if this is plus, this is minus. Now go to BMD. See. Now I will do one thing. I will put the SF ordinates here. 60 randomly. 60 comes down. This is actually 30, 35 comes down. This is 25 goes up once again. This is little lesser. Say 55 over. This is 55. This is SFD. Values you don't bother. BMD. See, BM values. These values are not required for me. Why? You calculate BM here, BM here, BM here, and plot the values. Our class is for variation. And see, sorry, one more thing forgotten now. See, regarding the variation, I should tell now only. Forgot. See, important point forgotten. Actually, this you can do one thing. In YouTube, one class, full board I explained that one. See, between two standard points, very important. between two standard points or salient points. If, see, different cases, when no shear force, then, see, remember now, between two standard points, you can do one thing now, briefly I will write, because I will let you know after going through my YouTube channel, exact class number I will mention, full board, I have written the statement very neatly. You take screenshot and hang on the wall. Then no shear force. Then when there is no shear force, no worry for, then SFD does not matter. When there is no shear force, what SFD? And then remember, your BM will be constant. That actually, that is called, anybody can tell, when there is no shear force, then shear force is not there. When it is not there, why should you bother? Then BM will be constant. And it is also called as, if you know it, anybody knows it? It is also called as, no problem, I will take a small break now. It is also called as pure bending. It is also called pure bending. Do one thing now, go to my YouTube class, pure bending. I will tell later what is the class number, pure bending. And when one point is over, when no load between two, no load, right? Everything is between two standard points. When there is no load, then shear force is constant and bending moment is linear variation. Linear, I won't write fully. Shear force variation, no space here. I will tell you YouTube page, class number. Take screenshot. Full board is there. Shear force variation is constant and BM is linear. Constant means x power 0, linear means x power 1. I use the same red color there, x power 1. Okay. Now, further. When, see here, between two standard points, when there is UDL, then ಆಗ ಕನ್ನಡದಲ್ಲಿ, okay, ಇರಲಿ, ಕರ್ನಾಟಕ, little Kannada, then shear force variation, see, someone will tell, shear force linear. You did not hear me. I told shear force variation. I am not that much full tight. Shear force is linear. Shear force is a value. Shear force variation. I told space problem not written. See, I get angry for such things. Just because I am not, I told, you see there in the YouTube other class, shear force variation is linear and BM variation is parabolic of second degree, that is also called as quadratic. That is here x power 1, here x power 2. Lastly, between two standard points, when there is UVL means can be like this, or can be like this, or can be like this, or can be like this, anything, uniformly varying load, then shear force variation is parabolic. Okay, parabolic, I will do one thing, color. Parabolic, I will go for color. Parabolic of second degree, that is x square, highest power of x, and BM variation is parabolic only, parabolic of third degree, that is x cube. This is the variation. Or you remember x power 0, x power 1, x power 2, x power 1, x power 2, x power 3. You can conclude power of BM is always 1 more than power of shear force. See, shear force constant, x power 0, BM linear. Shear force linear, BM parabolic second degree. Shear force second degree parabola, BM third degree parabola. In the YouTube class, Proof also is there. Beautifully proof is written there. And one more thing. No load, UDL and triangle load, power increases. Here also, see, if you go this way, shear post bending meant power increases by 1. X power 0 is X power 1. X power 1 is X power 2. X power 2 is X power 3. But if you come this way, power increases to X power 0, next is power 1, power 2. 1, 2, 3. This you have to understand. Okay, now I think I have to take some at least 4 or 5 minutes break, non-stop teaching. Okay, just 4 or 5 minutes break, I will come back. You do one thing, instead of wasting time, go through this one and understand. You go through that one. I will tell you in the next class why I can't search YouTube now. So next class I will tell you in the YouTube which is the class number where all these are told. Okay, just 5 minutes break. Little patience required. 5 minutes break. If you want to learn from me, all these class or any of the class, patience required. I don't do that emergency shortcut class. I can do it, not for professional knowledge. That is for students, where people want only to pass. Display okay? Okay, I won't change the display now because just Monday will ask some people who has got experience here. They will come and help me. I am searching. Someone told on Monday will come and give all the settings. So once the setting is clear, then there is no problem. Okay, now I'll continue now for a little more time. I will explain this case and one more case, small case, so that you get the confidence now. Yes, at least something we learned today. Instead of only speech, today you should not tell. Today you only talked, nothing you told, everything I told. Okay, 1 minute. I should hear that. Voice clear? Usual. Just tell me voice clear, sufficient. Voice clear means okay. No disturbance, voice clear. Just one comment, voice clear. If you tell voice clear, okay. No comment then, nothing further. Once that lag goes, then I will keep on asking comment with you. Okay, see. Now, see, this is a bending point diagram. See, between the, I will tell the point as A, B, C, D, E. Now see, between A and C, see, there is no loading. C point load is there, that is not important. Between the two standard points you see, between C and D also no loading. Between D and E also no loading. E and B also no loading. So, between A and C, between C and D, between D and E, between E and B, shear force will be constant. See here, constant, 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 parallel to baseline, or slope equal to 0. Correct? Rate of change of shear force is intensity of load, no intensity, so 0. Correct? For a horizontal line, slope equal to 0. This should be clear. Okay, now, why it came down all, that comes in SFD BMD. I am discussing variation. That you start from class number 1 and study. See what level it will take you. Have patience, 100 class over. I will upload 100 more, or if requirement is there, 150 more, or 200 more. So many cases I will cover. Nobody should tell later. If someone wants a problem, they should tell, go there. You see that one there. There is nothing there which is not considered. Okay, now come to BMD. See, you know, when you draw BMD, slope of BMD equal to shear force. See, now plus minus is not important. I will tell you what. See now, to the left of D, see, this portion shear force is positive, and this portion, see, shear force is negative. Now, positive, see, some people, same shear force diagram, they draw like this also. See, this also. In ETAP, you get this way. In the ETAP course, I will tell the reason, not now. So therefore, but sign what? They will take negative, positive. Don't bother that one. But one important, see, from A up to D, positive, B up to D, negative. Therefore, slope of BMD to A to D, where shear force is positive, and then D to B, where shear force is negative. Tell the condition, the slope of BMD this side and slope of BMD that side should be what? Anybody can tell? Sign not required. Should be what? Don't tell clockwise, anti-clockwise. Slope for this side BMD and slope for that side BMD. To decide slope for BMD, you see SFD. See, positive shear force, negative shear force. Positive, negative, not important for us. Some people will tell that also. First quadrant, second quadrant, all nonsense. Sorry, if anybody has seen online classes, see, sometimes I use such word because it is really nonsense they are talking. Okay, they should be what? You can tell at least. They should be what? At least tell that much. This side shear force positive, that side shear force negative. So, slope of BMD this side and that side should be what I want. Don't tell clockwise, anti-clockwise. They should be one word. One word. They should be Just one word. Opposite. That's all. Means they should be opposite. Remember now, permanently. So if this side slope is anti-clockwise, that side slope should be clockwise. Or if this side slope is clockwise, that side should be anti-clockwise. This side slope, for our case, see, for this line, this is the slope. For this line, see, this is the slope. For this line, this is the slope. For this line, this is the slope. See here, anti-clockwise, anti-clockwise, clockwise, clockwise. Correct. If I draw SFD, if I draw BMD, sometimes people draw BMD like this also. See, that is called BMD on tension side. Then for them, this side will be clockwise, that side will be anti-clockwise. So you don't by heart clockwise, anti-clockwise. Where shear force is positive, for that portion, slope of BMD can be either clockwise or anti-clockwise. But once you decide that one, other side, where shear force is negative, the slope should be opposite. Clear now? Slope should be opposite. This I will not tell now onwards. It comes for UDL, UEL also. This I will not tell once again now. If positive shear force side, if slope is clockwise, negative shear force side, slope should be anti-clockwise. Or if positive shear force side, if slope is anti-clockwise, negative shear force side, it should be clockwise. They should be opposite. You tell clear, sufficient for me. Clear, that's all. Now see, correctly tallies. Now tell me, what is slope? This is for a straight line, there is only one slope. You can mark the slope here, you can mark the slope here, you can mark the slope here, wherever you can mark. See, for this line, shear force is 60. So this slope should be 60. For this line, from here to here, shear force reduces to 35. See, slope should be 35. Correct? See here, this is steep. That is little flat. See, this is steep. Why? 60. That is flat. Compared this one, the slope should reduce. Then, when you come this side, see, for this line, slope is 25. Correct? See, 25 slope. Whereas for this line, shear force here is 55. Slope should be 55. Again here, this should be steep. This should be flat. Correct? This is explanation for point load. Okay, now, to wind up the class, I won't continue further. 9 o'clock, I will take a UDL case and make perfect. See, now you can understand a question. Sometime long back I used to ask in the class. I know nobody will give the answer. 1 minute now. See, cantilever beam, I will tell you, when there is a UDL is there, SFD will come this way. BMD, usually if I go to a college, if it is first time I am taking class there, otherwise no use. I will draw BMD like this. You should see the people shouting, sir, no sir. Why? Sir, not that way sir, wrong sir. Wrong, yes sir. Then tell me how. One student has come to the class, he came to board, he told sir, it is like this sir. He was about to go. Where I will not tell. I told him, stay back. You told me I am wrong. Tell me why this way? Both are parabola. This is also parabola. Why this way? Why not this way? What is the wrong? Sir, that I don't know. You do not know that one. You told me I am wrong. How dare you tell I am wrong? Yes, I was wrong. Deliberately. Deliberately I am wrong. I know BMD will come this way. And if a point load is there, tell the BMD. He will tell, sir, this way. No, BMD will not be that way. It will have some slope here. If the point load is not there, zero shear force will come. See, then SFD will come this way. Some slope will be there. So I made deliberate mistake. Little later, after 2 or 3 classes, they know that it was deliberate. I will tell them, if that much I am not knowing, I won't come and take the class for you. Their voice, no sir, that spirit. After 1 or 2 classes, spirit goes. Then if I ask a doubt, tell me something, they will tell, no sir. Why? Sir, no answer. Why means they know I am trapping. See, now, reaction is this way. See, I will take a simple example of W per unit length, that is the UDL. This reaction will be WL by 2. This reaction is WL by 2. Span is L. I will draw SFD first. How SFD comes? See, go up by WL by 2. These all you should know. From here to here, come down by WL. When there is a UDL is there, I told you, slope of shear force diagram is always what? Equal to intensity of load. For UDL, intensity is constant, or this is a linear. Constant slope means linear. So from WL by 2, it will come to minus WL by 2 here, and then join by a straight line. Okay, over. Plus, minus. Zero shear force will come here, exactly at center. L by 2, L by 2. This all are knowing. Yes, sir, we know this one. Yes. Okay, now, see now. Tell me, what is the slope of this plane? Entire line. See here. If you want slope of the entire line here, you can tell that slope equal to this slope. Correct? Or equal to, see, tan theta equal to, see here, WL by 2 divided by L by 2. L by 2 cancels. Oh, once again W only. So, slope of shearing force diagram is intensity of load. Since it is linear, nobody got confusion. See, nobody will have confusion. This everybody knows. I don't have to waste time. Now come to BMD. Okay, see. I will discuss shear force diagram when curvature comes. Then I will tell you, is the curve this way or curve that way? I will very thoroughly explain. See, I will very thoroughly explain. See, for example, if UVL is there of this type, the SFD will come this way. Not that much, it will go. Actually, it will come this way. Whereas, if UVL is of this type, then same SFD will come this way. See, curve. Here curve this way, here curve this way. These all I will explain. That is what so many people want. And that is what you want. You came to this class for learning. Nobody came here to learn this one. Now, start BMD. BM at A 0, BM at B 0. This is center. BM at C will come WL square by 8. This I am not explaining. Go back to my class, SFD BMD. It is thoroughly solved there. Why WL square by 8? You can see there. Don't bother here. Okay, now, joining. Sometime for fun, I will join this way. Just for fun. Again, people will start shouting. No, sir, wrong. If it is first class, they will tell wrong. Second or third class, they will tell, sir, like that. Why? They know I am playing a game. They will tell, sir, what? Sir, this way, sir. How you know it? Sir, how you know it is they don't know. They don't know the answer. Sir, it is people draw. People draw means why should you draw? People draw means why should you draw? You draw correctly. When I was going to school long back, around for 3rd standard, 4th standard, if I tell my father, everybody will do it. Kannadalli, ellaru ಮಾಡ್ತಾರೆ. He will tell, everybody will do bad things. Are you doing? No. Then don't tell that way. You do correctly. You are brought up that way only. If somebody, you tell, others are eating or some bad thing. Are you eating? No. Then don't tell, others are doing, I am doing. In a signal, all are jumping signal. Don't tell that reason. Everybody jumped the signal. I also jumped. Be a good citizen. Wait for the signal. They are not fit to drive the vehicle. Don't give respect to them. If others make mistake, why should you make mistake? Okay, now start. Now see. From A to B, single curve should be there. Why? Because UDL. Single curve means, see, it cannot be like this. See, then curve will go this way. So only possibility is this way, smooth curve. That is one of the reason. But correct reason, I will tell you here. See, correct reason. See here. Slope of BMD equal to shear force. See here. Shear force, maximum shear force here. Maximum shear force here. When you reach here, shear force equal to 0. Therefore, and when UDL is there, BMD will be parabolic of second degree, quadratic. So, it cannot be like this, because if you draw this way, see here, if I draw tangent here, see here, more slope. As I come here, tangent will have what? Lesser slope. No. See, when you go from here to here, slope decreases. When you start from here, come here, slope increases. So, here, BMD should be steep. It should be steep. Here, zero slope. It should be flat. Or, see, it should come this way. Then, see here, slope here is maximum. I already told you, if you want to decide slope for BMD, see shear force diagram. Okay. Somewhere here, see, shear force lesser. See there, it became little flat, lesser slope. As you go here, shear force further lesser. See, small slope. At this point, shear force 0. See, no slope. Slope equal to 0. Again that side, somewhere here, shear force increased, negative side, slope increased, but opposite. As you go here, shear force further increased, negative side, slope further increases here. When you come here, shear force once again is maximum, negative maximum. So see, slope is maximum here, slope is here steep, once again steep here, or maximum slope, zero slope, maximum slope. But see, here shear force is positive, slope came anti-clockwise. Here shear force is negative, slope came clockwise. Tell me, further not required. It will come. Why I am not telling further? Because this is a simple when you discuss so many things in future. Future means coming classes. So many things you will discuss. In front of that one, this is nothing. Right now, it may be new to you. When you study later little more concepts, then you will tell, hey, this is so simple. So, at least that point load case and the UDL case, tell me, fully clear or not? If it is clear, I will wind up the class. Tuesday you have to continue. If it is clear, I will wind up. Tuesday you have to continue. That was all old clear. Clear. Okay. I will stop the class now. Tomorrow and day of tomorrow, I am taking column design and footing design for my ETAP and SAFE batch. Only these two parts, because there, though it's a software class, I started and told structural knowledge is given. Beam design, slab design, everything is told there. So many things are told. And for column also, so many things are told about eccentricity and about the slenderness ratio, not slenderness ratio, L effective by side. Then some, which is the length to be taken. That all in the group add-on. But how to design the column when subjected to axial load and uniaxial bending or biaxial bending, and little later how to design the footing, that I am going to cover. This portion, column design and footing design, I will make public, because that is in the most demanding part. You tell your friends also to come live and utilize the opportunity. But once I finish the footing, then don't tell to continue. Then I will continue my batch only there. You won't get any link then. It will not be in YouTube. So those two parts, I decided, even I also see my channel to grow. I also need more views and more people to come to the classes. It is not called what, some little benefit for me also. Therefore I decided, okay, let the entire public know it. So many things I will tell. See, footing, principle also I am telling. Column, principle over. Nothing can be done. It is for them. Only design part, but very useful. Footing, even principle also I am covering. Okay. So this class, you will get the link on Tuesday. I won't send anything there. Simply I will send the link. If you subscribe it, you will get the link. Those subscribe, they get the link there or notification, attend the class. Okay, thank you. I will continue on Tuesday this class.